Okay, so we're going to be talking about the Monty Hall problem, and it's a famous problem that's been a classic in probability classes for almost 20 years now. And it used to be off of a game show called Let's Make a Deal, and we had a host on that time called Monty Hall. And Monty Hall would have a guest on or a contestant, and he would present to them three doors. We'll call this one A, this one B, and this one C. Now, we'll say initially that the car, which is the prize, that the contestant wants to get is behind door A. But the contestant doesn't know this. So let's just say this. The car is behind door A. Okay. So, Monty Hall asks the contestant, which door would you like? And the contestant will say, well, I would like either A, B, or C. Okay. Then Monty Hall opens one of the doors that he knows that the car isn't behind. He opens one of the doors and reveals a goat, which is the booby prize. Now, Monty Hall says to the contestant, do you want to stay with your original door that you picked, or do you want to switch to the other one? Now, what should the contestant do? Let's just, without loss of generality, we'll assume that the car is behind door A. The contestant doesn't know this, but we can actually do this using a probability tree. So the contestant picks either door A, door B, or door C. So we have these three outcomes. Now, if the contestant is picking this randomly, and we're going to say with equal probability, well, there's three choices. So the probability that the contestant picks A is 1/3. The probability that the contestant picks B is 1/3. And also the probability that the contestant picks C is 1/3. Okay. Now, Monty Hall knows which door each hides. So in door A, he knows that the car is behind door A, and that, say, the rest of the booby prizes, the goats, are behind B and C. So that means we can run through all the scenarios right now. So Monty Hall opens. Now, when the contestant picks door A, that means that the car is behind it. Monty Hall has two options. He can either open door B or door C, because he knows that there's no prize behind that. So he'll pick those randomly. He can pick between the two of them, and we'll assume that he picks randomly, so it's 1/2. And then we want to know if the contestant switching is better. So we'll say that the contestant switches to, and in this case, the contestant picked A, Monty Hall opened B, so all that's left is C. And in this case, where we have A, the contestant picked door A, Monty Hall opened C to reveal that goat, so he's left, or the contestant is left with the option of B. So that means the contestant will open that door with probability of 1, and this as well, because that's the only choice that's left. Now, if the contestant picks door B, means that the car isn't behind it in this case. That means that Monty Hall has to open a door that isn't this one. That's the one behind the prize, because he doesn't want the game to end yet. So Monty Hall will either open, well, he can't open B because that's what the contestant picked. He can't open A because that's where the car is. So that means he'll have to open door C. And because of that, and we're going to see if the contestant switches, that means that the only door that's left, because we can't use B, we can't use C because Monty Hall's opened it, so he switches to A. And so that will be probability of 1 as well. And lastly, if the contestant picks C, then Monty Hall has no option to open B because he doesn't want to reveal a car yet, which means that contestant has to switch to A. Okay, so we've done this probability tree, and right now, in this case, if a contestant switches to C, they don't win because that's not where the car is. And neither would they win if it was with B because that's not where the car is. But in these two cases, that's where the car is. They'll win. So the probability of this case happening, where a contestant picks door A, Monty Hall opens B, and the contestant switches to C, that's the probabilities of just us simply multiplying them along this. That it's 1/3 multiplied by 1/2 multiplied by 1. We got 1/3 multiplied by 1/2, which gives me 1/6. And similarly for this outcome in B, where the contestant switches to B, that's the probability 1/3 multiplied by 1/2 multiplied by 1. So I have 1/3 multiplied by 1/2 equals 1/6. Now for this one, it's 1/3 multiplied by 1 multiplied by 1. So that's just 1/3. And right here, this is multiplied by 1/3, 1, 1. So I'm just left with 1/3 here. Now, this is very interesting. The probability that the contestant wins by switching is 1/3 plus 1/3, which equals 2/3. And the probability of losing is 1/6 plus 1/6, and that's equal to 1/3. So the contestant winning the car, which is what they wanted, if they picked their door initially and then switched to the other door that isn't opened by Monty Hall, the probability of them winning is 2/3 compared to 1/3 if the contestant stuck with their original door selection. And that's the Monty Hall problem.